Hello, my name is Tankoon Katunchaleekorn. My student ID is 63105508996. I study on Sec 450. Okay, this is my student ID card. Okay, today I will be presenting to you the midterm project, combination logic circuit designs, which in this project I have designed a circuit which composes of three modes. First, mode 1. In this mode, I will design a circuit that it will display my student ID in their 7 segments. Next, mode 2. In this mode, I have designed a circuit that it will display the number in two complement system, which we will have both the positive and the negative numbers. Lastly, we have mode 0. In this mode, I will turn off all the display of the 7 segment for both digits. Okay, let's get started with mode 1. For mode 1, I decided to have the data input with 4 data input, which is B3, B2, B1, and B0, and the 7 outputs such as A, B, C, D, E, F, and G. The first data input 0, 0, 0 is nothing will happen. Next, the 0, 0, 1. The output will appear the number of 6 on the 7 segments, which will have the active high on C, D, E, F, and G, which you can see that if C, D, E, F, and G is active, it will represent the number of 6. Then we do it for the rest of my student ID 63105508996 here. So it will be the total of 10 inputs, and the rest that we don't use, we will insert it as don't care. And this is my K-map of mode 1. Okay, and the program I will be using today is Logism. First, I click on the project, then analyze circuit, then I inserted my input, which is B3, B2, B1, and B0. Next, the output A, B, C, D, E, F, and G. Then the table will appear. Now we insert our output according to the truth table here. Okay, now the rest are don't care, which in here is represent as X. Okay, let me check for a bit. Okay, Then we click build circuit. We name our circuit names 01. Okay, then there circuit will appear. Then click on the main circuit. We drag this circuit here, and we have the decoder with its name is 01. This decoder we have 4 input, which are B3, B2, B1, B0, and the 7 outputs. So let's insert our pin of this inputs. Okay, we have 4 with this 4 input represent B3, B2, B1, and B0. Then we connected it to our decoder. Alright. So now let's do it. Let's do our mode, the next mode, the mode 2. For mode 2, we design our circuit to make it display the number into complement 4-bit system through the 7 segment, which it will have both the positive and negative number. The first one, the data input we will be using is the same data input, which is B3, B2, B1, B0, and same output A, B, C, D, E, F, and G. First data input 0, 0, 0 represent number 0, so our output will be active except G. And we do it to the rest. The number 1, 2, 3, 4, 5, 6, 7, and next, when our most significant bit is 1, it indicate that the number will be negative, which here is negative 8, 7, 6, 5, 4, 3, 2, 2, 1. Then we have our truth table. Then and we also have our K-map. Then we insert our truth table to our program. Click. We do the same as the mode 1. We have input B3, B2, B1, and B0, and same output A, B, C, D, E, F, and G. Then the table will appear. When we insert our outputs of the mode 2, Alright, sorry it took so long. I input it the wrong output. Okay, we click build circuit and we name the circuit as 10. Then our circuit will appear. Then let's insert this circuit decoder to our main circuit and name it as 10. Okay, then we connected our data input to this decoder. Alright, now we have to add the multiplexer in order to select that which mode we will be using. For this multiplexer, we use select data of 2 select bits, and it will appear at 4 to 1 multiplexer. For enable, we don't use it. Okay. Then to connect our decoder to the multiplexer, we use a splitter. Okay, in this splitter we'll use fan out of 7 and bit width in 7. It's 52 ways. Okay, we connect it and we copy it because we need 2 splitter for both of our decoder. Okay, now we connect the decoder to our multiplexers. Okay, now our first problem will appear, the incompatible bits. In this, we have to select on the multiplexer and change the data bit to 7, corresponding to the output of the decoder. Alright, now that we have our decoder, multiplexer, and our data inputs, we have to have our selector signal for our multiplexer. So we use splitter, another splitter here. Set it to south, connected it to our splitter. Then we insert 2 more pins here and another one here. Select it to north to connect it to our selector signal here. Okay, let's name it as M1 and M0 because it is our selector signal, the mode selector. For the rest of the multiplexer, we connected it to the ground because it also indicates the mode 0, 0, the mode 0. Okay, ground. Okay, here is the ground. Also, the incompatible bit will appear. We have to select the ground data bit to 7. Alright. Now let's connect this multiplexer to our 7 segments. Okay, we get 2 7 segments, one for the number and one for the sign. Alright, and to connect our multiplexer to the 7 segment, we use the splitter again. Okay, splitter. Now we have the same 7 fan out and 7 bit. Connect it to the outputs of our multiplexer here. Okay, now we have to connect the output of the multiplexer to the 7 segment. Now the problem 2 will appear that we don't know that which inputs of the 7 segment represent A, B, C, D, E, F, G. To solve this problem, we'll select on the help and tutorial. Search there 7 and 7 segment display. This will tell you that which input of the 7 segment represent A, B, C, D, E, F, and G. Okay, now we connect to our multiplexer output to the 7 segments. First one. Zero, one, Alright, now we connect all the output of the multiplexer to our 7 segment. And for the rest input of our 7 segment, we connected it to the ground to avoid noise occurring. Alright, next we already have the 7 segment to display our number, but we have to design another 7 segment for sign the positive and negative. In this we make one AND gate. Okay, number of input 2, and we connected the B3 and M1. Okay, let's put it here to make it easier to connect. Alright, the reason I have to connect the M1 and B3 with the AND gate is that first, in order for the negative number to appear, the most significant bit have to be 1. And next, I connected the M1 to the AND gate is because this 7 segment will be used only when it is the mode 10. Then let's connect this output of the AND gate to this here to make the negative sign appear. Alright, now that we have designed our circuit, let's put it to the test. And this is my student ID 6310550850896. Okay, now first mode 01, which is the student ID mode. First input. Now the number 6 appear. Next, number 9, 8, 0, 5, 5, another 0, then 1, 3, and 6. Okay. Next, from mode 10. Okay, now that our data input is 0, 0, 0, the 0 appear, 1 appear, 2 appear, 3, 4, 5, 6, 7. Next to the negative 8, negative 7, 6, 5, 4, 3, 2, and 1. And for the test the last mode, the mode 0, we select M1 and M0 to 00 with, and then with any data inputs. Then the 7th segment doesn't display anything. 1, 2, 3, 4, 5, 6. Next, we can reduce our equipment by using XOR gate. We can apply the XOR gate. Example like here, we move this. Okay, 3. We connect it here. Okay, and we can remove this 2 inverter and have to select another gate here. And here we can do this and apply it to all of our circuit to reduce our equipment. And then for our total equipment use, I have used this 2 7 segment, 1 multiplexer with 2 select bit and 7 data bits, 43 AND gate, 14 OR gate, 52 inverter, 4 splitter, 6 pin, and 2 ground. Thank you.